All right, so we're talking now about these items that are called imaginary units. And what we have to know is that the square root of -1 equals I. The way that imaginary units came about is mathematicians were trying to solve problems such as x squared equals -1. Well, there's no number that you can take the square root of and get -1. So when they took the square root like this, they would get x equals plus or minus, but then they had no name for the square root of -1, so they decided to call it I. So that's where it was developed. So anytime we have a number like a plus bi, a and b are real numbers. That's any number you know of right now is a real number. Like radical 3 is a real number. 1.2579, etc. is a real number. Every number you know is a real number. A is the real part. Bi is called the imaginary part. And that's because of the I in it. An imaginary number means that for a plus bi, if b is not equal to 0, see, if b is equal to 0, this whole term just goes away, and then we're just left with the real number part. So if a plus bi, if b is not equal to 0, then we do have an imaginary number. Now, if we have a plus bi and a equals 0, but b does not equal 0, so a equals 0, so see how if a equals 0, we're just left with bi? Well, now that's going to be called a pure imaginary number. So a pure imaginary number would be something like 5i. That's a pure imaginary number. Whereas 2 plus 5i is just an imaginary number because it's not pure. It's got the real part and the imaginary part. All right, the square root of a negative number. So like I said, anytime we have the square root of a negative, that's going to be I. And then we still have this r. So in this example, we have the square root of -3. And I think of that as the square root of -1 times the square root of 3. Well, the square root of -1 is I, and then I just have radical 3. If I have I radical 3 squared, that means I have to square the I, and I have to square the radical 3. What do you think I squared is? If we know I equals the square root of -1, what is I squared going to equal? -1, right. Okay, so here we've got I squared, so that's going to be -1 times 3, and so that's going to be -3. Okay. All right, we're going to look at some examples here. First example, simplify the square root of -9. Well, I'm going to think of this as the square root of -1 times the square root of 9. What is the square root of -1? I. What's the square root of 9? 3. So if I have I times 3, whenever I have a whole number like this, I'm going to write this as 3i for my solution. See how when we had, in this case, we had an I and a radical 3? We put the I in front of a radical. Why do you think we might want to put it in front? Yeah. Yeah, you might think it's actually under the radical and it's not. That's why we put the I in front. Very good. All right, let's look at the next one. So we have 3 times, and then this is the square root of -1 times the square root of 25. I'm just breaking it down. And so 3 I can't do anything with. The square root of -1 is I. The square root of 25 is 5. How would we write that answer then, everybody? 15i, right? Now we're going to look at some special patterns for I. We know that the square root of -1 is I. We know that I squared is what? -1. You're going to want to write this down, guys. I to the third. Well, I know I to the third is just going to be I squared times I. I to the third is just I squared times I. So if I do I squared times I, what are we going to get? I squared times I, -1 times I is just -I. And then I to the fourth, I can think of as just I squared times I squared. That's another name for I to the fourth. So what is I squared times I squared? What's negative 1 times negative 1? 1. This pattern will continue forever. I to the fifth. Well, I to the fifth is going to be I to the fourth times I. Well, what's I to the fourth? And what's 1 times I? Just I. I to the sixth. That's going to be I to the fourth times I squared. What's I to the fourth again? 1. What's I squared? Negative 1. So it's going to be 1 times negative 1, which is negative 1. What if I have I to the seventh? Well, that's going to be I to the fourth times I to the third. I to the fourth I know is 1. What was I to the third? Negative I. We're just filling these in, Ryan. It's not on your paper. We're writing them in at the bottom of the paper. Then if we have I to the eighth, that's going to be I to the fourth times I to the fourth. So what's that going to be? Just 1. Now this pattern continues forever. Like I know I to the ninth. I'm not going to write this out again. What's it going to be the same as? Just the pattern continues. I, negative 1, negative I, 1. I, negative 1, negative I, 1. What's this going to be? I. What's I to the 10th? What's I to the 11th? And what's I to the 12th? Good. Now, I don't want to have to do that forever to do a problem that you might see on the ACT like I to the 100th. I can't sit here and take my time going I, negative 1, negative I, 1. I, negative 1, negative I, 1. It will just take me too long. The only thing I notice about this is I to the fourth, I to the eighth, I to the 12th. What are all those answers? And what's true of all these exponents? 4, 8, 12, multiples of 4, right? Is 100 a multiple of 4? Yeah. So what's this answer have to be? 1. Okay? I would now know what I to the 101 is, because I know I to the 101 is just I to the 100th times I to the first. So I to the 100th is 1. What's I to the first? Just I, right? So this answer would just be I. So what I'm going to do, like if I ask you to do this, I to say the 202nd power, I want to think of a multiple of 4 closest to this that's less than this. Let's jot that down. Closest multiple of 4 less than the exponent. The closest multiple of 4 less than the exponent. What is it? 200. So I'm going to think of this as I to the 200th times I to the second. And that's because I know I to the 200th. What's every multiple of 4 going to be? 1. So now this problem's just 1 times I squared. Do we know what I squared is? Negative 1. Right? That's the answer. Now, this is kind of cool too. I'm not sure how great our calculator is going to do with a very large number like this, like 200, but let's see what happens. You actually have an I button on your calculator. It's down here above the period. So if I do I raised to the 202, I think it's going to do scientific notation, but let's see. Yeah, it did. Okay, so that isn't really that helpful. If we did something more reasonable though, like I to the 20th, it'll be able to handle this. See how it tells me it's 1? Okay, I'm not sure where the breaking point is to where it can't do it, It gives a scientific notation instead, which doesn't really make sense to even use. Let's see. Let's just see like raised to the, I don't know, 64th. Let's do 63rd. See if it can do that. Okay, can't do that. Can it do I to the 67th? I wonder if it's because these are actually like I to the 63rd would be negative I, and I guess it just doesn't know how to write that. Oh, you know what? 3 times 10 to the negative 13 is really 0, so it's really telling me it's 0 minus I, so that it is telling me it's negative I, which is what it would be. Well, but then back here, what was this one that I asked it? So I to the 202 should be negative 1. Yeah, it actually does work, but you have to recognize that it's saying it's negative 2 times 10 to the negative 13 I. So this part is really 0. So the answer is really negative 1. Okay? But I'm afraid that not everybody's going to recognize this right here is really 0. The calculator is just trying to actually multiply it, and it doesn't do a very good job with it. All right, but either way, I want you guys to figure out this now, using either this rule or using your calculator. What is I to the 221st? What do you think, Anna? I is right. So what you're going to say, Maren? I? Yep. That's I. Did you do it on the calculator, or did you, okay, just use that rule? Because we know that this is I to the 220, which is divisible by 4, so then it's going to be just I. All right, good job, guys. That can be tricky for people. All right, let's go over to page 53. Sum and differences of complex number. This is very straightforward. To find the sum of complex numbers, all you're going to do is add like terms. So like these parts are like and the I parts are alike. So we're just going to add the like terms. So let's do this first example here. So we have negative 3 plus 4I plus 2 minus 3I. So this is like this. Okay? So we're just going to combine them. What do I get if I combine those two? Negative 1. So this is going to equal negative 1. And then what is 4I minus 3I? It's just I, isn't it? So it's negative 1 plus I. So that's going to be our first answer. Now we have the same thing, negative 3 plus 4I, but now it's minus 2 minus 3I. When we have subtraction, we have to distribute. So this is going to turn into negative 3 plus 4I minus 2 plus 3I. I just distributed the negative through. So what are we going to get for the real part? Negative what? And then what are we going to get for the imaginary part? 7I. Okay? So adding and subtracting is just like what you would think you would do. It's not really too difficult. And then in number 3, this is multiplication. What do we have to do on multiplication? We have to FOIL it out. Yep. So we have to do negative 3 times 2. I have to do the outers. That's positive 9I. I have to do the inners. That's positive 8I. The last times the last is negative 12I squared. Well, what is I squared? Negative 1. So this is going to be negative 1 times negative 12, because I squared is negative 1. So what's this whole thing going to turn into? Go ahead, Ryan. What is it?
6 plus 17I.
Okay, good. You are correct, because it's positive 12. So 6 plus 17I. Okay. All right, we're just going to do 2 from this next section. This is kind of straightforward down here. Okay, we're going to do numbers 4 and 6. So looking at number 4, I have negative 2 out in front. Then I have to break the square root of negative 100. That's going to have to be thought of as the square root of negative 1 times the square root of 100. So what is the square root of 100? 10. What's the square root of negative 1? I. So I have negative 2 times I times 10. So that's going to be negative 20I. Okay. For number 6, I have 5 times square root of negative 75 is going to be negative 1 times radical 25 times radical 3. That's my best representation for negative 75. So now I have a 5. This is going to be I. This is going to be 5. And that I can't do anything with. So now I'm going to have 25I radical 3. So remember, if I just have a number that's not under a radical, just a regular whole number, that goes first and then the I. But if I have a whole number, a radical, and an I, the whole number comes first like always, then the I, but the radical comes last. Okay, in 7 and 8, find the values of x and y that satisfy the equation. Well, this is a complex number and so is this. So I have to set my real number parts together. I got to set that equal to that because those are the real number parts. So then I know x is going to equal negative 3. Then I have to look at the imaginary part. So I have this imaginary part and this imaginary part. So I know then that I is going to have to equal negative y times I. I'm trying to solve for x and y. So to solve for y, I'm going to have to divide by a negative I. So what's anything divided by itself? Just 1, not 0, 1. So what's this answer for y going to be then? Yeah. So we would do the same setup over here. We would just say, here's our real part. So 44 has to equal negative 1/4 x. Here's our imaginary part. So negative 1/2 yi has to equal negative 7i. So solving this, I'd multiply by negative 4. That's negative 176 for x. Over here, the i's would cancel out. I divided by i's would cancel. What do I do to solve this? Negative 1/2 y equals negative 7. Multiply by negative 2. So y is going to be 14 on that. All right, easy enough. One more thing, guys. This one's a little tougher. Flip over. We're not going to do any of these practice ones. We'll do these tomorrow. But I want you to go down to number 15. Number 15. On page 54, number 15. Okay, this says to find the impedance of the series circuit. What this means is basically just finding the sum. Now, this right here, this is going to be in your book, and you're going to have to look at this. This is in your text book. Because this is like a little key. It tells you what everything means. So this symbol right here, this is your resistor. See how it looks the same? And it says that it's going to be measured in ohms. This symbol right here is just ohms. And it says that it's just going to be whatever R is going to be its value, is going to be its impedance. So this is just going to be 5. That's all I have to do for that. This does not mean I, it means ohms. And it tells me that it's just going to be equal to R. The inductor looks like this, that little squiggly thing, which is right here. This tells me this is going to be called L, and this is always going to be whatever L is times imaginary number. This is going to be considered imaginary. So for our case then, this is going to be 10I. Then this symbol right here with the double slash, like how this has the double slash, it has a value of 14 ohms. But it tells me that as far as its impedance, it's going to be negative CI. So here's the C value, 14. So this value is going to be negative 14I. So we're trying to find out what the impedance of this whole series would be. Well, all we have to do is add them together. So it's going to be 10I plus 5 minus 14I. And so the total impedance of the series sequence circuit is going to be 5 minus 4I. But you're going to have to look back at this, okay? You're going to have a couple of problems like this, and if you don't look at the key in your textbook, you're not going to know which one's positive, which one has an I, which one doesn't have an I. So whenever you see this symbol here, it's just going to be whatever that number is. Whenever you see that symbol, it's going to be this number with a positive I. And when you see this kind of symbol, it's going to be a negative this number with an I. And then just add them all up. It's not hard. Okay? Any questions? It's not too bad. All right, so we will finish the rest of this tomorrow. You've got your assignment on the back of your yellow assignment sheet. It's also on the board.